In this video, I will demonstrate how to correct for scanner tilt errors. These errors can occur if the scanner is miscalibrated or if you are scanning on an unstable surface like the top of a floating roof. So first off, how do we know we have tilt errors in our data? During visual inspection of our registration, we see that the scan layers are tight where we placed our fiducials. However, beyond that, the scan layers quickly start to deviate. I just want to mention at this time that correcting for scanner tilt is an advanced manipulation. You should not need to do this for typical projects. If I take two vertical slices of the tank, it is clear that something is not correct with this registration. We want to do fine registration again, but this time with the vertical tilt option enabled. Before we do that, we need to ensure we have horizontal fiducials at the top of the tank to help resolve the tilt differences. Once I have added the fiducials at the top of the tank, I can run snap fiducials. Once this is complete, I run the Align Tilt tool to rebalance the tilt errors between the scans. The Align Tilt tool will set the average tilt of the reference layers to plumb by rotating the model as a whole. This tool should always be run at the end of fine registration if you have modified the vertical tilt of any of the layers. In this scenario, the Align Tilt tool warns us that one of the scan layers has above average tilt error. If you get this warning, simply rerun the Align Tilt tool and omit this scan layer from the reference layers. Now, if we run check tilt using only scans 2 to 6, you will see that the average tilt has been set to plumb. Another telltale sign that you have a tilt error is if when you get to the bottom settlement analysis, you see a gradient of colors around a single scan location. This indicates that the data is gradually degrading along a single axis, in this case, running left to right. You will also notice that the area directly below the scan location is blue, indicating there is a very low standard deviation beneath. This is because directly below the scan location, there is no data from this scan that contributes to the quality of the data model. If this is the case, simply snap fiducials again and adjust the tilt. However, unlike the previous case where all the scans were tilted, we know that in this scenario, only one scan is erroneous. Therefore, we are going to adjust the tilt only on the erroneous scan. Since this is a single blunder and not a random error, we are not going to adjust the tilt on the entire data model because we know that the tilt on all the other scans are correct. When we run check tilt, what we will want to see is that the tilt on the other scans are unaltered and that only the tilt on the erroneous scan has changed. When we rerun the bottom settlement analysis, we will see that the gradient of colors we saw before has been rectified.